Hey guys, so I know the videos that I've been doing have been kind of a little long. So today we're going to focus on one very specific topic regarding derivatives, and that is the quotient rule. Now, this is pretty much the first thing I learned calculus-wise because you learned it in pre-calculus. And this is, I literally learned this maybe like a few months ago. So this is the limit as some variable. I like to use delta x because it means the change in x approaches 0 of a function f of x plus delta x minus f of x divided by delta x. That's a pretty poor division symbol. Yeah. So let's talk about what this means. Then we'll do a very quick, very simple example. Now, mind you, this will not work for all functions. It actually does not work for most functions, but we'll get to that. So f of x plus delta x. So what delta means in mathematics is virtually always going to be a change in. And here we want delta x to go to 0. So if you'll note, what we're really saying the derivative is a function at a certain point as delta x gets smaller and smaller and smaller. The change in x gets smaller and smaller and smaller. We want a very specific pinpoint answer. So let's try to take the derivative of x squared, see if we can do that. So what I'm going to do is I'm going to, so I'm going to write f of x equals x squared. And the derivative of x, I'm just going to spoil it, but we're going to walk through this, is going to be 2x. Now, there's a very simple way to do this with this thing called the power rule, but, the power rule of differentiation, but we're not going to get into that. We're just going to substitute and see if we can do this. Now, you will need to have, I would say, like an algebra, maybe algebra 2 level understanding of functions to solve here. And we're also going to substitute delta x for h just to make it a little easier on ourselves. So what we're doing is taking the function x squared and plugging in x plus h minus x squared divided by h. So let's do that. So what we're really saying here is f of x plus h squared. Let's get rid of the f of that. Sorry, there doesn't need to be an f there. We're simply plugging in for x here. So we have x plus h squared minus x squared divided by h. So to quickly clarify, remember, delta x, it's the same exact thing as h. You can use both variables, and both are very common to use, and they mean the same thing. A very small change in x. So what we did, all this is saying is that plug in x plus h wherever you see an x. So let's say f of x equals x squared plus 1. We're plugging in x plus delta x wherever we see an x. So instead of x squared, we're doing x plus h because that's what it's telling us to do. And then we're subtracting x squared because it's just saying subtract f of x, which is equal to x squared. And then we're dividing it by h, the same thing as delta x, right? So let's FOIL this out, and I'll give you a second to just look at that if you want to write that down and try to figure it out. So this is going to be x squared plus h squared plus 2xh minus x squared divided by h. So let's simplify this down a little. So the x squareds cancel out, right? X squared minus x squared. So we're simply left with it's a pretty poor square, plus 2xh divided by h. And this is going to give us So we have h squared plus 2xh divided by h. So I'm going to erase that now because we know we have that. And we can simplify this all the way down. And what you should end up getting is h plus 2x. And you might think we're done, but remember, the original, if we go back to it, we solve for this, but then it's the limit as delta x or h approaches 0. So if we write this with the limit, so let's say we have the limit as h approaches 0 of 2x plus h, which is what we had. All this is saying is 2x plus 0, and our answer is 2x. So this is how you use the quotient rule to find the derivative of a function. This was a relatively simple example and won't always work, but it works here. So hopefully this helps out someone. It was just meant to be a very straightforward and easy to follow video. Thank you.